So these notes pick up right where last Thursday's notes let off. So we started section 1.3. We did problems 1 through 5. Now we are going to jump in and do problems 6 through 10, and then we'll follow up one more day and do 11 through 20. So lots of practice on factoring with the GCF. So the first thing you want to do on these problems is to find the GCF. So off to the side, we're going to talk about how we make a 27x squared and how we make a 9x to the third.
1 times 27.
Good.
And 3 times 9.
Very good. And you all have factor sheets?
No, I just guessed.
Yeah, if you want to just do it in your head, that's fine. If you have a factor sheet, get it out. If you lost yours, you got to get your own copy. I only supply one per student.
I'm going to say 9.
Okay, so 9 is the GCF. They both have a 9. It's the largest number they have in common. This one has 2 x's, this one has 2 x's. Remember, we're looking for how much they have in common, the greatest common factor. So 9x squared is going to be our GCF. So I'm going to write a 9x squared in the front. And then I'm going to divide every term by 9x squared. What I get when I divide goes in parentheses. Remember, this is the complete opposite process of distributing. So what is 27 divided by 9? 3. And I had x squared, but I'm taking x squared away. So how many x's do I have?
1.
What? You had 2, you took 2 out.
None.
None. So you don't need any x's. All right, remember, when you're dividing with exponents, you just subtract the exponents. Back here you had 3 of them. You're taking 2 of them to the front.
1.
So you'd have 1. Good. And then 9 divided by 9 is 1. So 1x, or if you don't want to write the 1, just the x is fine. That is it. So remember, it's just like undistributing. We're pulling out the greatest common factor to the front. And then in parentheses, we're writing what we have left over. To factor something means to write it as a multiplication problem. So we're just taking this and we're rewriting it as a multiplication problem with distributing. If you want to check your work, you just distribute. See if you end up right where you started. If you did, great. Raise your hand if you have any questions. So here's number 7. We do it the exact same way. Now there's just 3 terms. So 2xy, 8y squared, and 12x squared. You don't necessarily need to make these lists because you have all of the lists in front of you on your factor sheet. If making the lists helps you see what's going on, then for you, definitely write it out. But these are just as needed. Alright, so there's the list for 2xy, 8y squared, and 12x squared. Focus on the numbers first. What's the largest number that's in all 3 lists? 2. Do they have any variables in common?
X and Y.
Hold on. Where's the x here? Nowhere. Where's the y back here? So what variable is in all 3 lists? No variable. It has to be in all of the lists, all 3 lists, all 3 terms to pull it out to the front. So in this case, the variables are not going to be affected. It's just the x. Whoops, I lied. It's just the 2. Sorry. Confusing myself. So I'm going to divide everything by that GCF of 2. None of the variables are going to change because I'm not removing any of the variables. So what's 2 divided by 2? 1. So this would be 1xy or just xy. Plus, what's 8 divided by 2? 4. You didn't change the variables, so leave them alone. What's 12 divided by 2? 6. Leave the variables alone. To check your work, distribute that 2 back out. So here we'd have 2xy, good. Here we'd have 8y squared, good. And here we'd have negative 12x squared. So this does check out. If you want to check your work, great. It is something you can just do quickly in your head. Like I just checked it without even writing anything. It took me about 5 seconds. So I would encourage you to do that just to make sure you have everything lined up the way it needs to be. What are your questions? All right, here's number 8. So give me a second to write it. We're going to do it the exact same way. We're going to make a list for 9x squared, 18x to the 4th, and 21x to the 5th. Alright, so in front we have 1 and 9, 3 and 3, and then x times x. Here we have 1 times 18, 2 times 9, 3 times 6, and 1, 2, 3, 4 x's. For 21, we have 1 and 21, 3 and 7, and 5 x's. Alright, so what's the largest number in all 3 lists? 9. I don't see a 9 back here. 3, very good. Alright, and then how many x's do they have? They all have at least 2. So that's the greatest number they have in common is 2. So 3x to the 2nd. We are going to divide everything by 3x to the 2nd. It's like pulling that out to the front of the problem. So what is 9 divided by 3? 3. And you had x squared and you're taking away x squared. So how many x's do you have? 0. So just don't even write it. Leave it alone. What is 18 divided by 3? 6. Good. I had x to the 4th. I'm taking x squared away. So how many x's do I have?
2.
Yeah, so x squared. Good. Plus 21 divided by 3 is 7. I had an x to the 5th, but I'm taking 2 of those away. So now I have x to the 3rd. Very good. You can distribute to check to see if this makes sense. If it leads you right back to where you started, then you know you're good. But I trust that we did this one correctly. Any questions on number 8? Is this all coming back to you after the long weekend? Yeah, good. Got 2 more and then homework time. Alright, here is number 9. Alright, so ways to make a 6. We got 1 and 6, 2 and 3. I'm going to list my y's. 18, we have 1 and 18, 2 and 9, 3 and 6, and 1 y. Back here I have 1 and 36, 2 and 18, 3 and 12, 4 and 9. Oh my goodness, this is a long one. And y, 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 y.
I'm going to say 6. No. Yes.
6.
No, 9. No, yes, 6.
How many y's? Just 1. You got to go with the smallest number of y's. Good. All right. What? Why didn't I start with the y's at the beginning? Oh, this one is bothering you? I don't know. Mixing it up, keeping you on your toes. Alright, so my GCF here is a 6y. So I'm going to divide every term by 6y. I'm going to write what I have left over in parentheses. What is 6 divided by 6? 1. And then I had y to the 3rd, but I'm taking one of those y's out. So that's y to the 2nd. Good. Plus, what's 18 divided by 6? 3, you had a y, you're taking a y away. How many y's? 0. Good. Minus 36 divided by 6? 6. Y to the 4th, take one of, I did that first hour too. Y to the 5th, you take 1 away, you have y to the 4th. Good. I get the answer in my head, and that's what comes out of my mouth. All right. There you go. Raise your hand if you have any questions. If not, we'll finish this up with the last example, and you can start your homework. Going once, going twice. All right, last one of the day. All right, I'll get working on the list while you're copying the problems. All right, now 3 and 7 are both prime numbers, so that's a pretty good indicator that as far as the numbers go, the biggest you're going to get is a 1. What about the variables? Yeah, so x from each. Good. Now, you could write a 1x if you wanted, but that 1's not changing anything. Dividing by 1 or multiplying by 1, none of the numbers change. It's kind of pointless, so I'm just going to get rid of it. What I'm really doing is just taking an x from each of these. So instead of 3x squared, now I would just have 3x. Instead of 7x to the 4th, I'll have 7x to the 3rd. And instead of 12x, I'll just have the 12. So you're basically taking every exponent and subtracting a 1 from it. That's because we're taking out a 1x. None of the numbers change because dividing by 1 doesn't change the number. All right, I'll leave that one up there for a minute. Any questions? All right, remember, these notes are still not done. We are picking up with problem 11 on Wednesday. We'll go all the way to 20, and then we'll be done with 7-3. 7-3 is very important, and it's kind of new and difficult, so we're spending lots of time on it.